All right. There are certain equations that are called quadratic. When you hear the quad, you would almost want to think 4, right? Well, it doesn't really work out that way. A quadratic equation will come in this form. A few things to note. It has to equal 0 for you to be able to solve. And then there is going to have to be an x squared term. That a, b, and c that you see right there are just representing numbers. They chose a, b, and c because it's pretty straightforward. It's the beginning of our alphabet. And they just chose different ones because they can be different, but they could be the same. You know, a, b, and c could all be 1 for all we know. It depends on the problem. So that's called the quadratic term, that's called the linear term, and that's called the constant term. What they're called is probably not the most important thing, but at least now you've heard it if you happen to hear those words again. This right here is called the quadratic formula. It will solve that kind of problem for you. The nice thing about quadratic equations is it has one formula that solves every single one of them. They are the only type of function that has one formula that solves every single one. So really, pretty impressive. Okay? And once we do one, I think you'll be all right, but here's how some people say it. It's the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. I know that some people do have it kind of set to the rhythm of Pop Goes the Weasel. Unfortunately, I cannot do that, but you may be able to find it on YouTube somewhere, or perhaps ask somebody who can actually do it. All right? But you say it to that particular rhythm. So you can maybe try it later, maybe focus now on this and try and figure that part out later. Okay. If we have time, maybe we'll see if we can find that, yes. I'm not sure what the tag would be for that, but we'll try to find that out. So here, would you agree that that little equation I've given you there is quadratic then, if you look at it? It's 3x squared plus 5x plus 1 equals 0. And is it in the form we want it to be? We want it to equal 0. Yes. And it's even in order. You want it to go x squared, then x, and then the one that has no x on it would be last, or called the constant. And so what I like to do normally is off to the side, just make a note for myself. Well, what are a, b, and c? Because you notice a, b, and c are in the formula, so I need to substitute for them. And a, remember, is always whatever on the quadratic term, whatever that number is out front. What do we call those numbers out front anyways? It does not begin with an R, it actually begins with a C. Coefficients. So A is 3. B is it positive 5 or negative 5? Yeah, there's a positive in front of it, so it's a positive 5. And then C is, because B is always whatever on there, C is always that constant left over. Is it a positive 1 or a negative 1? Well, yeah, because there's a positive on it. Okay. So now we know what to substitute in every single one of these places. The only thing I don't know what to substitute for is x. That's because I'm trying to solve for x. Right? That's the only thing I can't replace. So here we go, x equals. So the first thing it says to take the opposite of whatever b is. Well, b is a positive 5, so the opposite of that is a negative 5. Plus or minus, that's a symbol that some of you, we do that with square roots a lot, right? In geometry, normally we don't need both of them, right? But we have seen it. Square root of, now you're supposed to take whatever b is, which is 5, and square it. Right? That's what it says to do, to put b in. And then there's a minus in the formula, so we will write it down. And then just a 4. There's no way of getting around that 4 right there. How is the 4 attached to the a there? Is that added, divided? Yeah, times. And what I normally do is I just put it in parentheses like that. And so what is a there? It is 3, and then c is 1, right? Now here's what some people do wrong. They say divided by, and that's all they divide by. Actually, it's everything. Notice how I stopped there? You want to actually put your division over everything. And it's 2 times whatever a happens to be, which is, in this case, 3. So is there any questions how I found a, b, or c, or how I substituted them into the formula? Any questions on that? Really, that part's not that bad, right? I mean, there's a formula right there. It helps if you know the formula. Right? So now all we have to do is the algebra. Is there any part of this that's drawing your attention that maybe you should look there first to do the algebra or the computing? I think the radical kind of draws my attention because it's a grouping symbol. It says do this stuff in here first. So here we go. X equals, so the opposite of 5, we're going to leave that. We're not going to touch that. Plus or minus the square root Well, inside that square root, the thing that draws my attention is the exponent, because order of operations says to do that first, right? And so what is 5 squared? I think we all know that one. 25. Now, here's normally what I do. You have to, this is the most common place for a mistake in quadratic formula. So you need to find the strategy that's going to work for you. Personally, I just put the minus down, and then I figure out what is that. So I put the minus down, and then I figure out what it is. Because this minus right here, I've already written down. Okay, so I don't have to figure it out. So then you take 4 times 3 times 1, and we find out that that number over there is 12. Everybody agree with 12? All right. And divided by, all divided by. Everybody understand what I mean by all? So everything is divided by what? 6. So any questions on what I did so far? Have I done anything wrong? Anything? No? Nothing misleading here. So now let's go ahead, equals. So it's the opposite of 5, plus or minus square root of 13, all divided by 6. Now, if they ask you for the exact answer, well, there it is. That's exact. That's as good as you can get. Because do we know the square root of 13? Is that something you just know off the top of your head? Is that a perfect square? You know, now do we know the square root of 9? Yeah, we know that one, right? And do we know the square root of, say, 16? Yeah, we know that one. But we don't know the square root of 13, do we? And here's where not having a calculator is going to be relatively painful. You're going to have to borrow one from someone. So it's negative 5, because I want you to round to the nearest tenth, plus or minus. So if somebody could tell me the square root of 13, that would be incredibly helpful. 3.6 if rounded to the nearest tenth. Okay, so 3.6 all divided by 6. Does everybody notice how I transitioned that to just what it is to the nearest tenth? Everybody notice that's all that is, right? And so now all you have to do is actually figure out what those values are. I better put an equal sign there. So now you have to take negative 5 plus 3.6 and divide it by 6. That'll be one of your answers. So x will equal that. X will also equal, well, how is there 2 answers? Well, there is. X will also equal negative 5. We already did the plus one, right? We did the plus. Now we have to do the minus. And once again, calculator will be a lot easier than doing it by hand. Okay, so this one here and that one there. Let's see what we get for answers. Does anybody have the first one? If you took negative 5 plus 3.6 divided by 6, does anybody have that one written down? Chris? Negative 0.23, and so if we round to the nearest tenth, we'd say negative 0.2, right? So negative 0.2 is one of your answers. And what do we think about this other answer? Is it going to be negative or positive? Well, it's a negative 5 minus 3.6, right? So that's negative 8.6 divided by a positive. Is it going to end up positive or negative? Most definitely negative, right? So this one, negative, again, we'll go to the nearest tenth. That's fine. Yes. 1.4, that's believable. Now, some of you are saying, but what? Negatives aren't supposed to work, Mr. Brooks. Well, is there any picture involved with this? No, that's just a quadratic formula. And basically, that is the answers to the nearest tenth. So x equals that. And for those of you that are in Algebra 2, those are approximately the 2 places that that parabola would hit the x-axis. For those of you that know what a parabola is, not a parabola. Because remember, you put the emphasis on the wrong syllable if you say it that way. So any one step all that hard? Not really. Without a calculator, maybe. But overall, not that bad. So what I would like you to do for this one is tell me how it is different from the other one. Because is it quadratic? Yes. So why is it different from that one? Aha. Does it have to equal 0 to set up A, B, and C? Yes. So this one does not. I personally, now you don't have to, but I personally like the A to be positive. It is not a requirement. Okay, I think it's helpful though. What that means is I don't mind that's over there being positive, which means we got to move the other stuff to the left. So how am I going to get that 9x over to the other side? Yeah, subtract 9x, right, from both sides. How am I going to get that 5 over there? Subtract 5, right? So I'm going to have 2x squared minus 9x minus 5. Do you notice what order I chose to put them in? Did I have to put them in that order? No, I chose to, because now it's just sitting there, A, B, C. And now what does it equal? Because these canceled, those cancel, it equals 0, right? Because I moved everything else over, right? And what I'm going to do now is I'm going to do A, B, and C with you, and then I'm going to let you loose on this problem and see if you can get it done. So now, do you agree I have it in order? So what is A? It's just 2, just the coefficient. B is, careful, -9. C is -5. And now, go for it. Solve it. If you need to borrow a calculator from somebody, get to the point where you need the calculator, and then borrow it.